we will study the next topic, area of similar triangles. In this topic, we will study theorem 6.6, but its proof is not required. The proof is deleted from the syllabus for this academic year. So I am not going to prove this. I will only state the theorem because the application of theorem can be asked. Exercise 6.4 questions can be asked. Proof of the theorem is only deleted. Now what is the theorem you have to understand? The theorem is ratio of the areas of two similar triangles will be equal to ratio of the squares of their corresponding sides. That's the theorem. That is, if two triangles are similar, you suppose two triangles are similar, triangle ABC and triangle PQR. Triangle ABC and triangle PQR are similar, you suppose, is given. Then the theorem states that these triangles are similar. Both the triangles are similar. Then the theorem says that area of triangle ABC by area of triangle PQR will be equal to square of their corresponding sides. What is the corresponding sides? ABC similar to PQR, then corresponding side of AB is PQ, BC is QR and AC is PR. So the theorem says that ratio of the areas of two similar triangles equal to area of triangle ABC by area of triangle PQR equal to corresponding sides are square. That is AB square by PQ square. Or it will be also equal to BC square by QR square. Or it will be also equal to AC square by PR square. This is a theorem. You have to understand that. So again, ratio of the areas of two similar triangles. Those similar triangles का areas का ratio उन लोग का corresponding sides का squares का ratio का बराबर होगा. The ratios of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. So based on this theorem, we can solve some questions of exercise 6.4. Now the question number 1 is very easy. You can solve it using the theorem. Question number 2, I will try to solve it. What is question number 2? Diagonals of a trapezium ABCD. ABCD is a trapezium. The diagonals intersect at O. The diagonals intersect at the point O. If AB equal to 2CD, that is given, AB equal to 2CD, then find the ratio of the area of triangle AOB and COD we have to find out. We have to find out the ratio of triangle AOB and COD. What is given? AB is equal to twice CD and AB is parallel to DC because it is a trapezium. Now we have to prove area of triangle AOB and we have to find out the area of triangle AOB and COD. Now you know that triangle AOB and COD are similar, we can prove easily because AB is parallel to CD, then this angle will be equal to this angle. So angle 1 equal to angle 2. Why? Interior alternate angles, AB parallel to CD and AC is a transversal. So angle 1 equal to angle 2. Now angle 3 is equal to angle 4, vertically opposite angle. So in this way two angles will be proved. So what is there? Triangle AOB will be similar to triangle COD by AA similarity. So we can apply the theorem. Therefore area of triangle AOB by area of triangle COD will be what? We applying the theorem. It will be equal to squares of the corresponding sides. So let us take the corresponding side as AB and CD. So AB square by CD square we can write. But here you know that AB is equal to what? 2CD. So in place of AB square, we put 2CD square by CD square. AB is equal to 2CD. So AB we will write 2CD square by CD square. The square of 2 is 4. 4CD square by CD square is equal to 4 by 1. Therefore, the ratio of AOB and area of COD will be equal to 4:1. Now we will solve question number 3 of your NCERT book. That is question number, what is question number 3? Page number 144. In figure 6.44, ABC and DBC are two triangles on the same side BC, same base BC. If AD intersect BC at O, show that area of triangle ABC by area of triangle DBC is equal to AO by DO. Okay, this question is a confusing question since they have asked for area of ABC and area of DBC. Find the ratio of area of ABC and DBC. You may be confused that this we will use the ratio theorem, but here the ratio theorem has no application at all. This is a question of similarity only. So here, to prove, we have to draw a construction. That is, triangle ABC and triangle DBC are on the same base BC. We have to find out the ratio of ABC and DBC. We have to prove that it is in the ratio of AO by DO. AO by DO we have to prove. For that we have to do a construction. What is that? What is a construction? We have drawn AM perpendicular to BC and DN also perpendicular to BC we have drawn. That is construction. That you have to write. AM is drawn perpendicular to BC and DN is drawn perpendicular to BC. AM and DN are drawn perpendicular to BC. Now we use the area formula. The formula of area of a triangle. You know that area of a triangle is equal to what? Area of triangle ABC is equal to half base into altitude. So if we take BC as the base, then area of triangle ABC is equal to half BC into AM. Right? In the same way, area of triangle DBC equal to what? Area of triangle DBC, we take the same base BC. Then if we take BC as the base, then half BC into DN. Now let us find out the ratio of area of triangle ABC and area of DBC equal to what? Half BC into AM by half BC into DN. Okay? Half BC common, that will cancel out. It will come out to be AM by DN. Now, we can prove that these two triangles are similar. That is AOM and DON, we can prove they are similar triangles. Why? This angle is 90 degree. In both the triangle AOM and DON, angle M equal to angle N equal to 90 degree. And these two angles are vertically opposite angles. So by a similarity, we can show that AOM is similar to DON. The reason I have not written, you have to write the reason. What is the reason? In these triangles, angle AMO equal to angle DNO equal to 90 degree and angle AOM equal to angle DON, vertically opposite angle. Reason you have to write, and then you have to write AOM is similar to DON by a similarity. Therefore what? AO by DO, AM by DN equal to AO by DO. Corresponding sides are proportional. AM by DN equal to AO by DO. That is equation number 2. Now see equation number 1. What is that? AM by DN equal area of triangle ABC by area of triangle DBC equal to AM by DN. Now AM by DN equal to what? AO by DO. So from equation number 1 and equation number 2 we get the result. What is that? Area of triangle ABC by area of triangle DBC is equal to AM by DN and AM by DN equal to AO by DO. That is what we have to prove. Now let us solve question number 5. What is question number 5? DE and F are respectively the midpoints of the sides AB, BC, CA of triangle ABC. Find the ratio of the areas of triangle DEF and the triangle ABC. This question we have solved in class 9 using the property of parallelogram, property of midpoint theorem, whatever it is. We have solved this question. That is, we can show that area of triangle DEF is 1/4 the area of triangle ABC hoga. This we have solved in class 9 in some other way. Using congruency and using midpoint theorem we have solved. Again here also we use the midpoint theorem. What is that? We know that D is the midpoint of AB and F is the midpoint of AC. So line segment joining the midpoints of two sides of a triangle will be parallel to the third side and will be equal to half of it. So we take the second part, that is DF will be half of BC. That we will take. Midpoint theorem is what? Line segment joining the midpoints of two sides of a triangle will be parallel to the third side and equal to half of it. So we take, so BC, DF will be half of BC. In the same way, D and E are the midpoints, so DE will be half of AC and EF will be half of AB. Or we can take DF by BC equal to what? 1 by 2. DE by AC is also equal to 1 by 2. DEF by AB is also equal to 1 by 2. That is DF by BC equal to DE by AC equal to EF by AB. So triangle DEF का तीनों sides का और triangle ABC का तीनों sides का ratio equal है. That is equal to 1 by 2. Therefore, triangle DEF is similar to triangle CAB. That is the order, because we have to say DE equal to AC. So DE equal to AC, that is CA, that is no problem. So corresponding way we have to write. We cannot write ABC. Triangle DEF is similar to triangle CAB, we have to write. We cannot write ABC, we cannot write, because they do not come the corresponding. The corresponding side of DF is BC, DE is AC, and EF is AB. So in that way we have to write. Therefore, area of triangle DEF by area of triangle ABC equal to what? Area ratio of the area of triangle equal to ratio of the squares of the corresponding sides, or DF. We can take any side. DF if you take, then BC we have to take. So DF by BC the whole square. That is DF square by BC square only. We can write like this also. DF by BC the whole square. That is the theorem of what we have studied. DF by BC the whole square. And what is DF? DF equal to half BC. So we put half BC for DF, and then BC will cancel. That is 1 by 2 square. That is 1 by 4. The ratio comes out to be 1:4. This we have solved in class 9 using congruency and midpoint theorem. So we solved here it in another way using the similarity and ratio of the similar triangle property. Okay. Now we will solve question number 6 of the same exercise, exercise 6.4, question number 6. What is that? Question number 6, it is given that if the areas of two similar triangles, question number 6, prove that the ratio of the areas of two similar triangles is equal to the squares of the ratio of their corresponding medians. That is, it is given that a triangle ABC and a triangle PQR, we can take it as given, areas of the two similar triangles is equal to ratio of the squares of corresponding medians we have to prove. So what we can take it as given, triangle ABC similar to triangle PQR. ABC and PQR are two similar triangles, and AM and PN are medians. What is medians means? M is the midpoint of BC and N will be the midpoint of QR. Midpoint of ABC. And this will be the midpoint of QR. Therefore, AM will be median and PN will be the median. Now we have to, what we have to prove? Area of triangle ABC by area of triangle PQR equal to AM square by PN square we have to prove. See the proof. Since triangle ABC is similar to triangle PQR, triangle ABC is similar to triangle PQR is given. Therefore, what we can take? The corresponding sides ka ratio equal hoga. The ratio of the corresponding sides will be equal. That is AB by PQ will be equal to BC by QR. But BC by QR we can write as half BC by half QR. No problem. Half and half cut jayega, so BC by QR hi aayega. So BC by QR equal to half BC by half QR we can take. Then what is half BC? Half of BC is BM, because M is the midpoint of BC. So BM will be half of BC and QN will be half of QR. Half of QR. So BM by QN. That is AB by PQ is equal to BM by QN. Now, also angle B is equal to angle Q. Because triangles are similar, then corresponding angles will be equal. Angle B is equal to angle Q. Therefore, we can prove that triangle AMB is similar to triangle PNQ. Why? AB by PQ is equal to BM by QN and angle B equal to angle Q we proved. So by SAS, similarity, triangle AMB is similar to triangle PNQ. Reason you have to write. I have not written the whole reasons. Again I am saying AB by PQ equal to BM by QN and angle B equal to angle Q. Therefore, triangle AMB is similar to triangle PNQ by SAS. Now, therefore, what we can take AM by PN is equal to AB by PQ we can write. Now come to the theorem. What is that? Therefore, area of triangle ABC by area of triangle PQ are equal to, what is the theorem? AB square by PQ square. But what is AB? AB by PQ is equal to AM by PN. Therefore, AB square equal to, we can write AM square by PN square. That is what we have to prove. So we proved. Now come to question number 7. That is, this question is also important question. Both these questions are very important. And example 9. Before your question, there is an example 9. This example 9 is also an important question. You have to study from the example, see the example and understand it and study. That is also an example. That question is also important for your exam. Okay. Now question number 7, what is that? Prove that the area of an equilateral triangle described on one side of a square is equal to half the area of the equilateral triangle described on one of its diagonals. That is, what is that? ABCD is a square and DEA and ACF are equilateral triangles on side AD and diagonal AC. They are the equilateral triangles. Then what we have to prove? We have to prove that area of triangle ADE, the triangle inscribed on one side, triangle जो एक side में जो बना है, वो triangle diagonal पे जो equilateral triangle, दोनों equilateral triangle है, DEA and AFC are equilateral triangles. That is DAD equal to ED equal to AE होगा, equilateral triangle on the side, and AC is a diagonal, AC equal to AF equal to CF होगा. So this both are equilateral triangles. Then we have to prove that the equilateral triangle made on one side is equal to half the area of equilateral triangle made on the diagonal. This is what we have to prove. Now see, triangle ADE and triangle ACF are similar. Why? Because both are equilateral triangles. Two equilateral triangles are always similar. I have told you this in the beginning of the chapter. Two equilateral triangles are always similar because their sides are equal, so their sides ratios will be equal, or their angles are also 60 degree. In that way also we can prove that two equilateral triangles are always similar. Therefore, what is that? Area of triangle ADE by area of triangle ACF equal to corresponding sides. We can take any side. All sides are corresponding only in equilateral triangles. So we can take AD square by AC square. That is AD square by, what is AC square? AC is a hypotenuse. Hypotenuse. In right triangle, you know that square, this angle will be 90 degree. Therefore, AC square equal to AD square plus DC square we can take. AD square plus DC square we can take. But DC equal to AD only, because of square, all sides are equal. In square, all sides are equal. So, in place of AD we can take DC. In place of DC we can take AD. So, AD square plus AD square, that is 2 AD square. AD square cancel, then 1 by 2. Therefore, area of triangle ADE by area of triangle ACF equal to 1 by 2. That means area of triangle ADE equal to 1 by 2 half of area of triangle ACF we proved. So, I have solved many of the questions of exercise 6.4. Now, the next topic is Pythagoras Theorem. In Pythagoras Theorem, the proof of Pythagoras Theorem is required. Statement and proof of Pythagoras Theorem is required, but the converse of the theorem is again deleted. So in the next video, I will teach you the proof of Pythagoras Theorem, and the converse also I will explain, but the proof of converse of Pythagoras Theorem is not required. So wait for the next video to see the proof of Pythagoras Theorem and some questions related to Pythagoras Theorem. Okay.